Slow this moment down. A ball leaves someone's hand. It crosses the space between you, faster than you can consciously track. And a fraction of a second before it would ever reach you, your eyes are already shut. Your shoulders are already pulling back. Your whole body has already moved. You didn't choose any of that. There was no moment of decision, no instant where you weighed the danger and responded. Something acted before your brain had even identified what was coming, hadn't named it, hadn't confirmed it, and your body had already responded. Before we get there, what do you think your body is actually reacting to in that split second? Leave your best guess in the comments. Let's see how many people get it right before the science explains it. If you enjoy uncovering the hidden science behind everyday experiences, subscribe to Why Decoded. Every week, we decode another mystery your body has been quietly running without you. Layer 1. Most people assume protection works like this. Something threatens you, your brain identifies it, your body responds. Cause, recognition, effect. But you flinch before a punch that never lands, before a needle touches skin, before a loud sound finishes registering as sound. There is no confirmed danger yet, no injury, no certainty. And still, you move. So the first thing to let go of is the idea that flinching is even one thing. It isn't. A sudden loud noise triggers the startle reflex, a whole body contraction organized in milliseconds by circuits in the brainstem. A sharp, painful touch triggers the withdrawal reflex, a response so fast it can complete its circuit through the spinal cord and pull your hand away before pain ever reaches your brain. A fast-approaching object triggers the defensive blink reflex, a separate system built for one job only. 3 different dangers, 3 different circuits, all faster than the thought, "I am in danger," could ever form. But none of that explains the ball. Because a ball isn't loud. It isn't touching you. So what exactly told your eyes to close? Here is where the science becomes extraordinary. Whatever closed your eyes acted before your brain had time to finish identifying what it was even looking at. Something in your visual system was watching for one thing, and one thing only. Not what the object was, what it was about to do. Layer 2. Your visual system contains a specialized sensitivity to something called looming. Not to the object itself, not to its color, shape, or name, to the rate at which its image expands across your retina. In the natural world, one specific pattern, an image growing rapidly larger, symmetrically from all directions, means almost exactly one thing. Something is about to hit you. Certain neurons appear tuned specifically to detect this expansion signature, and they can trigger defensive responses before any part of your brain has confirmed what the object even is. Your eyes didn't need to recognize ball. They only needed to detect the shape of a collision happening in real time. And if that's true, it changes everything you thought you knew about reflexes. Pause on that for a moment. Sometimes, recognizing the pattern is enough. And now, the moment in this documentary that should genuinely change how you see your own brain. Research suggests these defensive responses to looming appear remarkably early in human development. In developmental studies, very young infants showed consistent defensive responses to an approaching shadow simulating a collision before extensive learned experience of danger could plausibly account for it. This is not evidence that the nervous system already knows what danger is. It is evidence that it appears prepared, long before extensive visual learning occurs, to detect the expansion signature and respond to it. The circuitry arrived already sensitive to the pattern. Layer 3. If your eyes detect the collision that quickly, how does the rest of your body know what to do about it? The looming signal doesn't stay in your eyes. It feeds into a broader network of fast defensive circuits, including a structure called the superior colliculus, which helps coordinate rapid visual orienting and defensive eye and head movements within a larger distributed system. Not a single command center, one critical node in a network built for speed. And modern neuroscience suggests that rapidly acting subcortical pathways, including networks that may recruit the amygdala under certain conditions, can flag potential danger before the slower, detail-oriented cortex has finished its analysis. Speed first, certainty later. But if your body keeps reacting to patterns instead of complete information, is it just improvising? Or is there a deeper principle running underneath all of it? Layer 4. Many neuroscientists describe what just happened through a broader theoretical lens: predictive processing. The idea that your brain is constantly generating expectations from incoming sensory patterns, rather than passively waiting for complete information before acting. It's an influential framework, not a settled explanation for every neural event. But it captures something genuinely true about what your nervous system just did. It didn't wait to be certain. It acted on the best available evidence. The nervous system appears optimized to favor speed over perfect certainty whenever milliseconds matter. The question is, can this system change?
Layer 5. It can. Boxers show measurably reduced flinching to incoming strikes. Not from one cause, but several working together. Habituation, sensory motor learning, motor preparation, sharpened expectation, and top-down regulation from higher brain regions. The reflex hasn't disappeared. The brain has simply learned how much of it to spend. But there is something else this system is constantly recalibrating, and this is the part that connects directly to your own life. Stress, anxiety, and fatigue can heighten how strongly these fast protective systems fire. The exact same stimulus produces a noticeably bigger flinch under pressure than it would on a calm, predictable day. A sense of safety quiets the system. Uncertainty sharpens it.
So if you've ever wondered why the same slammed door barely registers on an ordinary afternoon, but sends your heart into your throat during a week when everything already feels like too much, now you know. Your nervous system wasn't malfunctioning. It was recalibrated. Which explains something else you felt 100 times. You flinch at a jump scare, even knowing with total certainty that nothing on the screen can hurt you. Your rational mind knows you're safe. Your looming detectors, your startle circuits, your defensive network, they don't consult it in time. The correction arrives. It's just already too late to stop what already happened. Your brain really does work like that. Right now. Every time. Now, return to the ball. Leaving someone's hand. Crossing the space toward your face. You know now what was actually happening in that instant. Not prediction. Not foresight. Not some mysterious sixth sense. A signature. An image expanding across your retina in the exact pattern of an approaching collision, detected by circuits built to respond to that pattern alone, and translated into a protective response before you ever understood what you were protecting yourself from. Your eyes closed. Your shoulders pulled back. Your body moved. Here is the thought worth leaving with. Flinching is usually described as losing control for a moment. That description has it backwards. The fastest decisions your body ever makes aren't really decisions at all. There's something faster, older, and quietly more sophisticated than a decision could ever be. Protection, arriving before consciousness even had the chance to weigh in. And it has been doing exactly that, quietly, automatically, without asking, every day of your life. Was the science what you expected? Go back and check your prediction in the comments. And here is the question worth leaving open.
The next time your body reacts before your mind catches up, what do you think you'll notice that you never noticed before? Leave it below. We read every one. If you're curious about how your mind and our world really works, subscribe to Why Decoded. Because everything has a reason. We just haven't decoded all of them yet.